Good morning students. Today I am going to give you a presentation on cardinality ratio of an ER model, the flat file database, and the structure of a relational model. Now you remember in my earlier presentation I have discussed about the three different components of an ER model. The first component is the entity. An entity is an object of the real world. For example, materials such as gold, silver, and platinum can be an example of an entity. Animals such as dogs, cats, and cows can also be an example of an entity. And cars such as Lamborghini and Ferrari can be an example of an entity. Every entity is distinguishable from the other. An entity is represented in the shape of a rectangle. For example, if student is the entity, it should be represented in the shape of a rectangle as shown in this slide. An entity also has attributes. Say for example, if student is the entity, it can have attributes such as its name, age, blood group, etc. Now considering name as the attribute, which is denoted as S-name for the entity student, the attribute will be represented in the form of an ellipse. And there is another component which is the line. This component links the entity with the attribute. So for the student entity and the attribute S-name, the line connects or links the entity student with the attribute S-name. Now let's come to the topic cardinality ratio of an ER model. Sometimes the cardinality ratio is also called as the type of relationship between entities. There are three types of cardinality ratio that is possible in an entity relationship model. The first one is 1:many or 1:many. The common example for this 1:many cardinality ratio is the relation between state and city. This is because one state can have many cities. That's why there is a 1:many relationship between state and city. Next, for the 1:1 relationship or 1:1 relationship, the common example is the relation between country and its capital. This is because one country can have only one capital, and that is an example of a 1:1 cardinality ratio. Again, for many-to-many cardinality ratio or M:M cardinality ratio, the relation between class and teacher is an example. This is because one teacher can take many classes, as well as a particular class can have more than one teacher. So there is a many-to-many relationship between class and teacher. Now consider the ER diagram as shown in this slide. This ER diagram consists of two entities, student and device. And there is a relationship between the entities student and device. And the name of that relationship is purchase. That means a student purchases a device. The entity student has three attributes, that is SID or the student ID, the S-name or the student name, and S-city or the city that the student lives in. Then there are four attributes for the entity device. The first one is DID or device ID. The second one is DName or the device name. The third one is DCost or the device cost. The fourth one is DProfit or the profit associated with the device. Again, the relationship purchase, which is represented in the form of a diamond, also has two attributes. First one is QTY, which means the quantity of device purchased, and the next attribute is PUR date, which means the purchase date of that respective device. Now, what do you think can be the relationship between the entity student and device? Since a particular student can purchase many devices, as well as a particular device can be purchased by many students, so the relationship between the entities student and device is many to many, or M:M. Now again, if you are to find the relationship between student and purchase, that means a particular student can purchase many devices, so the relationship between student and purchase is 1:many or 1:M. Again, if you are asked to find the relationship between purchase and device, then a particular device can be purchased by many students. So again, there is a 1:many relationship between device and purchase, which is represented as 1:M between student and purchase, as well as 1:M between device and purchase. But remember, the relationship between the entity student and device should be M:M. Okay, this is because if a student can purchase many devices, then a particular device can also be purchased by many students. So the relationship between the entity student and device is many to many, or M:M. Now come to the next topic, which is the flat file database. A flat file database is a relatively simple database system in which all the records are stored in a single table. Now consider this table named student device. It consists of two pieces of information. The first piece of information is related to the information of students, which are represented by three different columns or three different fields, which are SID for the student ID, SName for the student name, and SCT for the city belonging to the student. Then the second piece of information consists of information pertaining to the device, which is being purchased by the student. So for the device, these are the fields which represents the device. The first one is the device ID or DID. The second one is the device name or DName. Then device cost or DCost, the profit associated with the device or DProfit, QTY or the quantity of device purchased, PUR date or the date of purchase of the device. Now if both the pieces of information, that is the information pertaining to students as well as the information pertaining to the devices, are stored in a single table called as student device, then it becomes a flat file database. So the flat file database uses a tabular form of this sort to represent the data and also to answer different types of queries associated with this table. Now let's say if you are asked to find the students who visited the store on 25th December 2013, then you need to check this table again. Look at the purchase date, which is 25 December 13 in our case. Now, which are the students who have visited the store on this particular date, that is 25 December 13? Now, come here, check the student name. The student corresponding to that field student name is Tushar, and this Tushar purchases a device on this particular date, that is 25 December 13. So the student name is Tushar, and that's why the output shows student name as Tushar, who have visited the store on 25th December 2013. Now if you're asked another query to find the name of the devices available in the store, so how can you find that? Now, in order to find the name of the devices available in the store, you need to look at this column or this field, that is dname. And for this field, the list shows 3 devices. Those are RAM, pen drive, and DVD. That's why the output shows the field device name or dname having 3 items, which are RAM, pen drive, and DVD. Now come to the next topic, which is the structure of relational database model. The structure can be represented in 2 ways. One is the theoretical model and the other one is the implementation model. We call this whole figure as a table, and it is represented by the name student_device in the implementation model, and the same can be called as relation in the theoretical model. These column names such as SID, SNAME, SCT, DID, DNAME till pure date, these column names are known as fields in the implementation model, and the same is known by the term attributes in the theoretical model. Now again, consider this row, which is in the shape of a rectangular box holding the data items S10, Arpita, Bangalore, D10, RAM, 850 till 26 Jan 13. This row, which is in the shape of a rectangular box, is termed as record in the implementation model, and the same is termed as tuples in the theoretical model. So we can say that this table has 3 records in the implementation model, or we can also say that this relation student device has 3 tuples in the theoretical model. So the terms fields, records, and tables are used in the implementation model, whereas tuples, attributes and relation are used in the theoretical model. Now it is very easy to find the number of columns of the table. We also say the number of columns as degree of the table. Now considering this table, how many columns we have? For SID, SNAME, SCT till PUR date we have, just count it, 1, 2, 8, 9. So we have in total 9 columns. Okay, we have in total 9 columns for this table. So we say that the degree of the table is 9. Just count these fields. Again, what's the cardinality of the table? Now considering this table, you are required to find the cardinality. The cardinality is nothing but the number of rows of the table. So if you are required to count the number of rows, just count the records. Records represent the rows. So how many records are there? This is the first record, this is the second record, and this is the third record, as represented in the shape of a rectangle. So the cardinality or the number of rows of the table is 3.